Hi, my name is Noah Gift, and today I'm going to cover Pytest tips and tricks from ground zero. We're going to start out at really building the foundational knowledge for Pytest, like what are the structure of the projects that you need to care about, like the Makefile, the Docker file. Also, what is testing, what is DevOps. Then I get into building this out from scratch using GitHub and also GitHub Actions and GitHub Codespaces, and then move later into some of the advanced features of Pytest, like skipping tests or running tests in parallel, and then actually verify the speed increases based on using big machines. And then I later move into the AWS Cloud9 environment and integrate it with AWS Code Build to test out how you could do a full AWS Cloud Native configuration. All right, let's go ahead and get started. So what are the key components of a testing system? Let's actually make this a little bit bigger here. Let's do this. So that's pretty good. So what are the key components of a testing system? Well, I would say one of the key components is really the build system is at the heart and soul of all testing. And so if you are going to be a tester and you're going to do the things with Pytest in particular, it is important to know about a build system of some kind. And fortunately, we're blessed with many different options for build systems in the world we live in today. Some of those build system options include, we have GitHub Actions really is probably the most popular, I would say, in the world right now in terms of just adoption. There are pure open source alternatives, and probably the one that is the most popular in terms of pure open source would be Jenkins. And then we have the kind of the cloud ones that I just discussed here. And in the cloud world, really the three top clouds are, you have AWS, and you have Azure, and you have GCP. Although there are some significant other clouds, including Oracle Cloud, Ali Cloud. There's other clouds, especially regionally, that seem to play a big role. And then there also could be just doing builds locally, right? And so I'm assuming, though, for the most part, people are using one of these build systems. So it's just important to know that that's the thing that's going to use the test that you write. And now, if you do this correctly, there shouldn't be really a change amongst all of these systems, right? The build system should be able to run any test that is created if the structure is correct. And so what I would recommend for a structure would be to think of the structure as a scaffold. And in terms of the scaffold, there are a few different options, but for Python in particular, what I would recommend would be, for the most part, a Makefile is a huge component of building tests. And the reason why I like a Makefile, and if you're not familiar with a Makefile is included with all Linux and Unix-based systems. So the Make system has been around for decades. And so one of the reasons why a Makefile is a reasonable place to orchestrate the commands for testing is that it's probably there. Just like there are other tools on Linux, like Vim, for example, that are probably there as well. And you should know a little bit of Vim. A Makefile it's got that same legacy. And so if you orchestrate the commands for your build with a Makefile, it makes it very simple to transition to GitHub Actions, Jenkins, the cloud-based build systems, because you always do the same command. And that's really the advantage of a Makefile, is it's a way to uniformly run testing commands. Now, for a Python project, I would also say most of the time you're going to have a requirements file as well. And there are options available like different build installation systems, for example, that are always coming out. But for the most part, the requirements file is the most widely adopted in Python. And if you use pip install, it's a reasonable approach. Now, there also, most of the time, is going to be a test directory or test files, and then your source code. So we'll just say the convention typically would be test underscore lib, or let's say we have a library here, and then inside of here also you would have, I don't know, lib, right? So that's kind of the core of the structure as well, is these core components. And most of the time as well, you do have to manage a couple different aspects of running things in Python. And typically that means either a virtual environment, and so we'll say virtual env, or as well Docker. So it could be both. It could be both. You may want to have both Docker and virtual env. And the reason for this is that Python, because it's a scripting language, has some issues in terms of reproducing the exact same package structure. And the issues are that it will pick up everything that's on the file system because of the design of the language. So if you have a machine that's running Amazon Linux 2 versus maybe Ubuntu or Debian, it's possible there'll be slightly different behavior because whatever is already pre-installed on the machine will be picked up. And so it is important to use a tool like this in development that can isolate all the libraries to basically be excluded, and you only work on the libraries you want to work on for your build system. So this typically is very critical. Now you can do the same thing with Docker. That's one of the things that's nice about Docker. But in general, I would say this is the lay of the land when you're building out an infrastructure, and this pattern will fit across many different things. Now, because we're going to cover some of the basics here, I want to dig a little bit deeper into defining some of these terms. So defining the reason for a virtual environment, defining the reason for a Docker file, and also defining the reason for a Makefile, and then the reason for a requirements file. The reason for me defining these is that, in particular, those four things, I get asked about them quite a bit, and it would be good to explain them. So let's start off with another diagram here, and we'll say key terms in testing. So go through here and call this key terms. So to start with, the requirements. Let's just go into this and talk a little bit more about the requirements. So the thing about the requirements file is it's a convention. It isn't a hard requirement that people use requirements. You don't have to use a requirements file. The reason why people do use a requirements file is that you can put a list of the packages that you're going to install inside of the requirements file. That's really the key reason for a requirements file. And even further, you can actually find out what the exact version was that was installed, 1.0.1, and you can basically make your build system only install that exact version. And there's pros and cons to this, but I would say more pro than con. And the reason for this is so that it's 100% reproducible. And that's part of what testing is making things more reproducible. And so in the scenario here where you have a pinned version, you don't have to worry as much about someone 2 years from now or 5 years from now, looking at your GitHub portfolio, doing a git clone, and then nothing works, right? That conceptually, there are some edge cases. For example, you don't necessarily control the sub packages underneath that are inherited, and someone could do something strange. And every once in a while, something like that happens. But for the most part, it prevents like 99% of reproducibility issues because you've pinned your version number. So it is, I think, a very good idea for both open source and also commercial is to pin your version number. Now, the next thing to discuss here beyond the requirements file is the Makefile. And as I mentioned here, I think there's a lot of confusion about this for people that haven't used Makefile. It's like, hey, what do I want this? Like, this is, I don't understand what this is, or it's not available on Windows, and that's true. So a few things to be aware of about a Makefile is that Windows, it doesn't work, right? So if you're on the Windows operating system, unless you're running Linux on Windows, which is pretty funny that's now available, you can't use, Windows doesn't work. So that's just one thing to be aware of. Now, in practice, that's not that big of a deal because you can run Docker on Windows. So it really doesn't matter. You could always build something inside of Docker if you really needed it, or you could just develop in a cloud-based development environment. So that's one thing to be aware of. But really the syntax here is that the subcommands inside of Make, these commands here are a form of automation, right? So we'll say commands equal automation. And that's really the reason for this. Why do something over and over again in a brutal way? So if you had to put slightly different commands in cut and paste the same code all over the place, you're going to create a brittle build. And so a Makefile allows you to just build the same command and do the same thing on every build environment. So you can say make test, and the make test will work both locally and it will work in the build system. So that's really the reason for the Makefile. And as I discussed earlier, that the Makefile is available on all Nix, systems, right? Basically Unix type systems, Linux type systems. The other key term to define is actually Docker containers. And this is also very confusing to people, for a good reason, because there's different components of it. So first of all, there is a Docker file itself. And that's the first thing to really get out of the way, is that a Docker file really is a plain text file that lives inside of your source code repository that defines what will be in the runtime when you do later build the Docker format container. So there's a difference between the Docker file versus the container that later gets built. And the container, though, if we go to the container, why would we want to build a container for our project? And this is really a fairly recent evolution of software engineering. The reason to do this is that you want to have the runtime as well as the code itself, your software, included in the same system, right? And so what's nice about this is that in the case of a container here, the runtime will have the libraries, the Linux operating system, the packages that are necessary for it, and also includes your software. So you're making things more reproducible. So really what's interesting about these three things in particular, what do they all have in common? They make your project more reproducible. So that's really a key aspect of testing, is that what does testing do? It makes your project more reproducible, right? So they're all part of this concept of really the Kaizen, or continuous improvement. So ultimately, what are we driving at when we get to all these things? Well, if we go to this concept of Kaizen, which is the core principle behind DevOps, what Kaizen means is continuous improvement, right? So we're continuously improving what we're doing. And the reason for this is that this is the only way to build reliable systems, is to build something that is able to improve what's happening versus stay the same or decline. Really, this is the core concept that is important to be aware of. Is as I'm testing, I'm continuously improving the software. As I'm building a Docker container, I'm continuously improving the runtime. As I'm enhancing my Makefile, I'm continuously enhancing the way I can build a project. And also as my build system goes, I'm continuously improving. So really the key concept here and why this is essentially equal to DevOps is that there's 3 states that you can be in. There's state 1, which is degrading. There's state 2, which is the same. And then there's state 3, which is improving. And the idea here would be that hopefully you're always in either the same or improve. But if you don't have automation, it's a guarantee that you will have a degrade of your system. So testing really is a way of at least keeping things the same. But it's possible if you don't have any tests, it actually is almost 100% the case that your system will slowly degrade over time. So that's in my opinion the whole reason for this, because once you have the testing, you have the automation, you have the Makefile, the runtime, all this, then you also can practice continuous delivery, which is the final step. And once you do continuous delivery, then you're constantly improving your production system by deploying the tested version of your code into a production-based environment, right? So I think it is important to understand the concepts and why people do testing, why people do Docker containers, why people do all of this, and what's the theory behind it in order to kind of improve and get things to the next level. So now that we have the concepts behind, let's start slowly building this testing infrastructure out. So what I would recommend to build things out is GitHub is typically a reasonable place to do this. And I'm going to use a new repo here, and we'll call this Pytest from ground zero, like that. And put a note here. This is a new Pytest repo that covers the best practices. So a few things to be aware of is that now there is a new concept where you could actually create templates, which, for example, could be a good concept to get into if you're building the same kind of structure all the time. But I'm going to build this from scratch here. Also, adding a README file is a good idea so that you can have documentation and show people how to reproduce the project that you're building. And then this is another one that I think is easy to maybe gloss over. It is a gitignore file. Why would you add a gitignore file? The reason to add a gitignore file is so that the common files that cause problems in your project, you would pick it for your language. In this case, maybe I would pick Python, and it wouldn't check in that code, right? That would be the advantage of adding the gitignore. And then in terms of a license, you can pick some kind of a license. I always pick Creative Commons because I do a lot of content stuff, and then go ahead and create our project. Now notice that there is a marketplace as well, and you can actually hook into other cloud-based providers. Like in this case, I had in a previous project I was working on, integrated Google Cloud Build. There's also Azure DevOps. There's other kind of cloud-based builds that you can add. But I'm going to mostly use at the beginning here the native GitHub Actions build here. So I'm going to go ahead and click this, create a repository. And then once I've got this, I can actually just share this out with other people. And that way other people can get access to this. Okay, so got this repo ready to go here, and I'm going to build it out. Now, a couple things to point out. when you're first starting with writing tests from zero is the place that you're writing your tests in. And we just talked about this. There's a reproducibility issue to consider. Now, what I could do to make things, I think, a little more reproducible is to set this up on 4 different development environments. And the reason why I would do that would be to show that you can uniformly do the same approach in any cloud-based development environment. And I would even recommend to people that are doing testing to avoid, if possible, starting with your laptop. I think a browser-based testing environment typically is a good place to start. So the first one that I can start with here is using something called Github Codespaces, which is a cloud-based development environment. So I'm going to go ahead and go to Codespaces. You can see this. This is a feature that's available to enterprise customers. If I want to, let's say, delete one of my old ones, so I have some room here, I'm gonna go through and go back to this project here. Yeah, here we go. And now I can say, if I refresh, I should have a ability to open up a code space. There we go. So it says, welcome to cloud editing, edit, debug, and run your repo without local cloning and setup. And this is really nice if you're developing with the GitHub ecosystem because it has deep integration. I don't have to worry about SSH keys. I also have integration with the environments for doing GitHub Actions, which is the testing and build system. And if I go through here and I create this, it's a one-click button to be able to create this. And notice what it does as well is it creates a container, which is kind of nice. And I also can go to the color theme here and I can swap it out for Visual Studio theme and make it a little bit easier to read. But the core concept here is that I can, if I want to use just GitHub, I could have a very inexpensive laptop and just use a browser and even go to anybody's house or the library or wherever, and I don't have to do anything. It's all set up in a cloud-based development environment. And I think there's a lot of advantages to that approach. But what we can do here is I can actually start to build out the scaffold of the testing project first here, then I'll open up different cloud environments and show how it's 100% reproducible to do the same thing in those environments. So to start off with here, the first thing that I would create would be just the structure of the project. So I would say a Makefile would be one of the things I would create. I would also create the requirements file, which I just talked about. And then I would also create maybe a test file, right? Like a hello test file here. And then I would also create the script that I'm going to test. So we really only need about 4 files to get started. The other thing that is important to be aware of is, and this is something I'll point out with the virtual environment, is if I type in which Python, notice that it says home codespaces.python current Python. So it's giving me this Python, and if I say Python 3, it's got running Python 3.10, right? So I have some idea of what's happening on my system. But what happens if I type in, for example, some kind of a pip command? If I say pip freeze, this will tell me all of the packages on my system, and I do word count -L. So there's 117 libraries already installed. So this is really an issue because, and we can look at these libraries, and the reason why is that what if I don't want to use TensorFlow version 2.8? What if I don't want to use Wrapped or Seaborn? Or what if I want to use a version that's older than that? right? Or newer than that, and there's a conflict. So this is why it is not a great idea to just kind of start without creating a Python virtual environment. Well, on one hand, it's kind of neat that they kept this version ready for me and there's these libraries all installed. And if I'm just toying around, it's okay. But for building like a real world production testing environment, this is really bad, right? Because I've actually introduced a bunch of non-deterministic behavior that will be different based on a different environment that I work in. And so maybe I'll add a little note here that says about note on virtual environment. We'll say something like check out how if you run this command, there are many packages you may not want. And it's very common that there's conflicts between packages that you don't want, right? They're introducing a dependency in your code that you don't need, and that really can cause issues. So this is why you do want to go ahead and create a virtual environment. And it depends on what system you're in. In this case, this is a Debian-based system. And so there's a tool called virtual env. So in this case, I would say virtual env and tilde. And I like to put it in the home directory. And there's a bunch of different ways to test your project conventions. I either call my virtual environment .venv or I'll name it the name of the repo. Because of the GitHub Codespaces concept, and there's typically a 1-to-1 ratio, it does make it kind of neat in that I don't necessarily need to run multiple virtual environments on one machine. I can probably get away with just doing this. And now, and we'll put this inside of here. So we'll say step 1 would be to go through here and create it. And then step 2 would be, I would say, edit your bash rc file. So we'll say vim tilde.bash rc and put it in. Put in this command, which would be source tilde.venv bin activate. There we go. So basically, in this particular environment, I'm going to edit the bash rc file here and actually automatically source the virtual environment. So let's go ahead and do that. And I say bash rc. And if I go to the bottom of this file, you could do Shift to G, gets you to the bottom, and then O to open a new line. I can put a comment that says, always source this virtual environment, and then put that command in. And here we go. Source tilde/.venv bin activate. Perfect. We've got this sourced. And if I close this out here, what do we do next? Well, what we do next is that I can actually just open up a new shell like that and notice that it automatically sources that virtual environment. So I'm going to get rid of the other one. And this is the advantage. Now, if I open up yet another shell, same thing. And if I type in which Python, notice it's a different Python now because it's using the Python interpreter that's in this location. And so this is probably a good thing to verify is just say, try this command, try which Python to see this. And then if we run that same command, verify the right Python, right? We say which Python, and try that same pip freeze command, right? Now this should be 0, and that's really the win here that we're accomplishing. Is let's try it. What happens if we do pip freeze 0, pip freeze or pip freeze, and then count how many libraries? 0, right? So hopefully that puts to rest the concept of a virtual environment, because I have had many people ask about it. Like, why do we need it? What do we need it? Well, this is why, right? This is a mathematical, proof that you need it, right? That there's 0 in one situation and there's 100 something packages in another. We don't want those packages at all, because I'm trying to build 100% reproducible system that works even beyond what's happening inside of my GitHub Codespaces. So I'm going to go ahead and check that in. So we'll go ahead and say git status. And I'll notice that all these files are available. Now, this is where the git ignore is so helpful too, because if I can do this, I can say git add star, because I have the git ignore, and I don't have to manually type in all these files now. And that's the advantage of a git ignore, is it protects you and actually adds an automation step so that I can check in all these files at the same time. So we have hello, Makefile, requirements file, test file here. Let's go ahead and do this. And now if I go ahead and I say git commit, we'll just say, adding scaffold. There we go. And now I can do git push. And if I go back to my repo, you see all this stuff is available, so, which is kind of neat. Now, something to point out here would be that we only built the documentation about some notes here. We really haven't done anything yet. And so probably the first thing to do would be to put things in the Makefile here, and also to put things inside of the requirements file and make a little bit of code. That would probably be the first place to actually wake it up a little bit and make it do anything useful. Now, one of the things that I've done is I've already created Makefiles so many times in the past that I typically will just copy one that I've got earlier. And this is why maybe building some kind of a template would be a good idea. But I'm going to just grab one that I had recently and just copy it. And I'll explain what these tests are. So if we go to a Makefile and I just paste this in here, what am I doing here? Like, why do I care about this? Well, the install step here is basically telling us that I don't want to have to type in pip install -- upgrade pip, because pip always needs to be upgraded. And I don't want to have to actually manually type in all these flags. It's a lot less work to just type in make install. And then when I later go to the build system, imagine how brittle it would be if I had to take all of these commands and paste them into a build system file. It could easily, I can make a typo, but it's very difficult to make a typo if it says make space install, right? That's one of the advantages. Similarly here, that I have a test file that is being tested by Maketest. And if I want to format my code, I can say make format. If I want to lint my code, I say make lint. What I typically do with linting is as I disable with Pylint the recommendations and the configuration, which are too noisy for me, and I only keep warnings, which I do want, and errors. And so this is my typical lint file. And then from here I can say install lint test, and if I want I could even add format, right? Because these are I think typical steps that are common for me when I work on a project. So how do I actually get the testing itself, or at least part of the testing working? Well, first we need to install the libraries. And so what I would typically do is start there when I first build out a project. So the libraries I almost always use are Pylint. I use Pytest, which is what we're going to cover extensively today. I also use the formatting tool Python Black, right? So we can build these out easily by just typing make and then install. And notice it depends on the system you're in and how much auto prompting they have enabled. But in this case, I can actually type in I can even type in make and tab, and look, it'll show me all the things that are in my Makefile, which is pretty cool, right? Because again, I don't have to do as much work. And so now I can say, oh yeah, which of these commands do I need to run without even necessarily needing to look at the file. And I can say, oh yeah, I want to do make install. Okay, let's try that, make install. And then this will go through and it will find the latest versions of all the packages and put those in. Now, as I talked about earlier, I like to do reproducible libraries. And so what we could do now is run that same command. In fact, let's get rid of, we have two, I don't want two terminals, I just want one. And let's type in the pip freeze command. Now, one of the things that I'll recommend for people that get into testing is to use the history command. If I type in history, what does it do? Well, it shows me every command that I've run. And then I don't have to necessarily do all the work of typing the same thing again. All I need to do is find the line that I want to execute and just put an exclamation point in front of it and do that, right? So I want to run line 12 again. There we go. And we see now there's 20 libraries, right? So we've installed just the libraries and the sub libraries that are these libraries depend upon in our project. So what can I do? Well, I can actually run this one, which is $8, which is pip freeze, and we can see all the different libraries that are available. What I typically do is just look at it this way visually, and especially if I only have a few projects that or a few libraries I'm working with, I just paste in the version I care about. So okay, let's use Python Pylint 2.13.8. Okay, what about Pytest? Okay, this looks good. This looks like this version will work for us. And then I also can use this version of the formatting tool, which is Python Black. Great. Okay, we've got these libraries available. And then you could test it again by typing in, make install. There we go. Okay, now that I've got that working, then I would say the next step here for us would be first checking the code. So git status. We see that I've changed the Makefile, the requirements file. So let's go ahead and git add star. We can say adding local install step and push that code. So the next step for me would be to go, now that it's checked in here, and set up the build system and actually get the installation step running, and actually always be installing the latest versions of my library as a way to really start this continuous improvement process. And then also allows me to start to build out the other cloud-based development environments. So far, what I did was I created a GitHub repository right here. And this is this GitHub. And inside of GitHub, I was able to create my structure of my project and also launch a cloud-based development environment called Codespaces. And what's nice about Codespaces is the tight integration here. What I'm going to do next is I'm also going to launch a build system here, which would be GitHub Actions, build system, which would be GitHub Actions. Yeah, GitHub Actions. Actions. And inside of GitHub Actions, this is going to go through here, and it's going to have this feedback loop where we're gonna test initially. We're going to test the installation process, but later it'll run those other Makefile commands. Once we've got this set up, though, we can actually test in many different environments. So we can also have an AWS Cloud9 environment, which I'll set up and I'll explain how that works. We can also set up both Google and also Azure as well. So GCP, and we can set up the Azure. All of these will be fine environments to work out of, and they all can kind of work on the same principle. Now, what is interesting about this is that the cloud itself has unique properties, and one of the things to be aware of about the cloud is this concept of infinite or near infinite compute. A good example of infinite or near infinite compute with the cloud is that Amazon S3. Can you guess how many objects are in S3? Well, I'll tell you how many objects are in S3. It's 10 to the 14 objects. I believe it's in the trillions, basically trillions of objects, right? So this thing can scale, right? We don't have to worry about it. So that's one. We'll call this A. That's one core property of the cloud. But the other one is this concept of basically making things ephemeral or disposable, and that's a core property of cloud computing, is that you can set up and rip things down and make them elastic. And that is why it's not a big deal to just spin up new environments and always have a one-to-one relationship. So it's possible you would want to create multiple virtual environments in one, let's say, Cloud9 environment, but most likely what you would want to do is actually just create a new Cloud9 environment. So let's go ahead and do that next. Let's go ahead and take our installation step here, which we have working just locally, which is the install step right here. And we're going to expand this install step to all of these other environments. And also I'll show how easy it is to actually kind of make new cloud environments. You can almost think of it as, like a file. It's really an ephemeral thing, and you can use them on demand, right? So we're using I would call this a cloud native approach, which is we're doing new types of software engineering that only are possible when you're using the cloud in the form that it is now. We're not inheriting necessarily legacy techniques that were around in the pre-cloud era. And so in order to do that, all I need to do next year is first set up my GitHub Actions environment. So I'm going to go back here, and we have the same repo. All I need to do is run this. I need to click this Actions button here. And a few things to point out here is that when you go to GitHub Actions, that depending on what it is you're doing, it may be a good idea to take a look at some example, a deploy process, and just copy exactly what it is they tell you to do. And in this particular example here, that was the Amazon's Elastic Container Service. You could also use things like Terraform, Google Cloud Engine, Tencent Kubernetes Engine, etc. Security, continuous integration. All these are great examples. We can take a look at this one. So you can learn a lot by actually just copying some of these existing projects here. Now, I'm going to go ahead and do this. I'm going to just copy one of these projects here, and let's go ahead and do this. Let's just check this in, and we'll tweak it a little bit. So first, we see here that this GitHub Actions file, it's a YAML file, and it says Pylint. It says every time I make a change to my project, I want to run it in this particular flavor. I want to run it on Ubuntu latest, and I want to test in a matrix style. So I want to test Python 3.8, I want to test Python 3.9, and I want to test Python 10.3. And notice that in this place it says install dependencies, Python-m install upgrade pip install Pylint, and then this goes through and installs Pylint. And this is actually a really good example of something that we can actually change. So notice here's Actions, we have Pylint, and look, it completed and was able to run all these tests. But I want to actually tweak this because I actually want to make things actually a little simpler than this. And so what I'm going to do is I'm going to go back to my project here, and I'm going to say git pull like this. And I'm going to go to now this GitHub workflow here, and I'm going to tweak things a little bit. One is I'm going to rename the file, and I'm going to call this potentially testing. So we'll go ahead and do, or we'll say build. I think build is a better generic word. So we'll say change into .github. Let's go into this workspace here, cd into .github and workflows. And what we can do is we can say mv Pylint. We'll call this the build.yml file. And then also what I can do is just call this the build. And that looks good. And now what do I need to change? Well, first of all, this install dependencies, I think this is too complex because it's basically, it's good for an example to someone, but it's less reproducible than what I already have. Because I have a Makefile, all I need to do is just swap this out. Look, that's one line of code. So let's go back here, and in fact, this should be it should be renamed here. Let's see here. Oh, I see. Move. Well, I'm gonna get rid of the. Let's get rid of the Pylint file here. So we'll say. Let's rm build. We'll say git mv Pylint to build.yml. There we go. That was the problem, is I didn't use the git move. Okay, now that I got this thing, all I need to do, this is okay where it says install dependencies, but let's swap this out for something much easier. So I can delete this line here. I don't need it. And I can say make install. Just like this, make install. And notice how much simpler that is. And then if we do want to keep this Pylint step, sure, we can say analyze code with Pylint. I don't actually necessarily need to do it the way that they're telling me to do it. I can actually take some of their ideas. I can copy this and go back to my Makefile, and let's actually let's compare the commands. So this concept, I think is kind of a cool concept here. So let's keep that, but I don't want to do the generic Pylint because it's too noisy, right? I want things to fail only when there's real problems with it. So I'm gonna just tweak and take some of their ideas here, and then in order to test the lint, we need to have something in here. So let's just make a fruit function, and we'll say def fruit, and we'll just say let's say from random import choices, and say def fruit return choices, and we'll call this fruits. Let's just make a simple thing here: apple, banana, and cherry. There we go. And we'll just return choices. We'll return one of those choices of fruits like that. And if I say print fruits, this should give me something. Okay, if I run that and I say Python hello, well, actually, let's get out of here. And I just say Python hello. There we go. We have random fruits. So, and actually want to double check here. Yeah. So we have a little bit of code here, and if I want to do make lint, let's go ahead and test it out. It says there's an issue, and the issue is that the Makefile itself, I believe we're gonna have to escape escape the $sign in the Makefile, which is kind of annoying, but all I need to do is do a double $sign to escape it. There we go. So we can still use their fancy command here to test our code. And if I want to verify that it indeed breaks, I could put something below here like var equals 1, and then do var, like do something silly that will give me a warning, right? Because this, you don't want to redefine a variable. If I say make lint, there we go. So we see that it actually works here. So we actually have two steps in our Makefile, right? We have the install step and we have the lint step set up, and those are actually reflected into this build process. So this is I think a good spot to check in all this code and now start to build out these other cloud-based environments. So I'll go ahead and comment this out to start with here. So we have the build working, and then I'll say get status. There we go. We have all this. Git add.github, git add makefile, git add hello, and we'll go ahead and commit this, adding Pytest in the Makefile, or adding Pylint in the Makefile, and GitHub Actions. Okay, perfect. Things are working as expected, which is great. And if I go back to GitHub here and I click on Actions, we're going to be able to run 3 different build systems: 3.9, 3.8, 3.10. Let's go ahead and try that out. And I do like this matrix build here. Uh-oh, we got some problem. Analyzing code. Invalid syntax. Did I not fix that code? Let's go ahead and verify here. Make lint. Invalid syntax. Oh, I left. It caught a real bug, which is great. So there was a bug in there, which is always why it's a great idea to actually run the lint locally before you actually commit it. Now, if I take it, we can see. So I can just run those same commands again: git add star, git commit, and then push. So it's actually proof that the build system is working the way we want. We're testing 2 things: the installation, and we're testing the linting. Okay, we got this working here. Now we're still having a problem. Trailing white space. Oh, because it's testing things not in the way I want it to test things. So let's look at the Makefile real quick. And so that's what this is doing. But notice that I didn't change this, right? I didn't change it to the Makefile, which exactly highlights the other problem that I brought up, which is that you really don't want to get caught in the place where you have 2 different ways you're testing your code. You have this weird, complicated command that's just in the build system and like something totally different in your Makefile. Let's just make it real simple, right? And let's just say make lint, right? And that's really the advantage that is being highlighted here, is that you keep all the complexity abstracted into the Makefile. So now that we've done that, we should have exactly the same test process both in the remote build server as the local build server. So I just say get status, say get add.github. So we're changing that and say using make lint, and let's go ahead and push this change. Third time, hopefully, is the charm here, and we'll go through using make lint. All right, post setup Python 3.8, perfect. So we got it all working here, and it's completely reproducible, and we're testing 3 versions of Python. So now it's time to move to another environment, right? So let's start to build out a more kind of comprehensive test infrastructure, and even write our first Pytest. So the next thing I would do is I'm going to go to AWS console here, and I'm going to log in and use my 2-factor auth here to set things up. Perfect. And if we go inside of here, I'm going to go to the service called Cloud9. Actually, let's actually be very, very verbose. And I'm first going to open up CloudShell. So if I click on CloudShell, this CloudShell environment is basically a very simple shell, and it runs Amazon Linux too. And if you want to do very quick and dirty coding, the CloudShell could be potentially one of the ways to handle that. So let's go ahead and wait for this thing to wake up. And I guess, again, while it's waking up, the thing to point out about the CloudShell is that it has all of the goodies for AWS pre-installed. So if you wanted to maybe count how many buckets you have, or which is object storage, you could do that. So for example, if I wanted to say AWS S3 LS, and I want to count the number of buckets I have, notice it shows, there we go, I have 96 buckets available for me. And what's great about this is that I have this deep integration to the AWS cloud, but I can do the same thing that I was just doing in the other GitHub Codespaces, because the concepts are almost identical. And so how do I do this? Well, I go to Pytest from ground zero, and I go to my repo here and grab the SSH connection. So let's go ahead and do that. Let's just say git clone, and go ahead and clone this. And because I previously have worked inside of this particular environment, my GitHub keys are working, which is nice. Now, I probably would want to be a little careful in this kind of environment, because if it's something it's more of like a generic environment, I probably would want to create multiple virtual environments depending on the project that I worked on. So what I do in that case is I would say here, I would say Python 3-im venv, because this one uses the built-in Python virtual environment that's included. So Amazon Linux 2 has this version. And if I do a dot, what I like to do if I'm working with multiple repos is on one cloud environment, I'll actually put the name of the repo in the virtual environment. That way I don't get lost. And if we do this, then all I need to do is source this, say source /dot pytest from ground zero, bin activate. And once I've got that set up, if I type in which Python, here we go, tilde, I see it's this version of Python. Now, what happens if I type in Python? Here we've now introduced something that we should basically take care of, which is if we go back to the GitHub Actions here, notice it's neat that we have basically the ability to test Python 3.8, 3.9, 3.10, but look, we're not testing Python 3.7. Even further, we should probably put this, make a status badge, copy this, and put this into the root of the directory here, just so that we see whether the build works or not. So let's go ahead and put that here. And maybe we even put some notes here, like testing for multi-cloud. So first step, we would have AWS CloudShell. And if we need to put notes, we can put some notes there. But that looks good. And I'm going to go back here and I'm going to do a git pull. Oh, whoops, I need to go into Pytest, Python, or Pytest from ground up. Let's make sure I'm in the right repo. Yeah, here we go. Pytest from CD into Pytest from ground zero. And now I can do a git pull. And so if I do basically a make install, that's the same thing that the build server did. So we know that works, which is nice. And then we also could go through and do a make lint. That should work, right? That's great. But let's go ahead and change our, if we do ls-la, you can see the GitHub repo here. Let's go ahead and change that file because we wanted to test Python 3.7, right? Because that's the environment we're in. We don't want to just guess. That's what's really important about setting up continuous integration testing with Pytest is we want to actually have the testing set up here for the Python version that we're on. So let's go ahead to GitHub, workflows, build.yml. And here you can see that all I would, in theory, need to do is add one more Python version inside and say 3.7. Okay, so that looks good. And let's go ahead and say git status. And we can see that that's the file I changed. .github workflow build. Let's go ahead and commit this. Adding 3.7 Python or 3.7 Python, not 2.7. I have used Python 2.7 in the past, but we're doing 3.7. Okay, and then it's gonna ask me to do a little bit of configuration. Sure, we'll do that. And there we go. And I'll go ahead and say git push. And let's do the commit, make sure that works. Push, there we go. So if we go back to our build process here, we're adding Python 3.7. Look, there we go. Now we have 3.7, 3.8, 3.9, and 3.10. And we've tested our code, or at least we've got part of the testing infrastructure set up for two environments, a generic CloudShell environment and also the GitHub Codespaces. And let's just let this thing go. Okay, great, it works. So now let's move on. We already tried CloudShell, we know it works. Let's open up a new tab here and let's go to Cloud9. So Cloud9 is more similar to the to basically GitHub Codespaces. It's like Amazon's version of a rich cloud-based development environment. And so we'll call this one Pytest from ground zero. And we'll say this is my Pytest playground. And we can go through here and change things a little bit. Now, a few things to point out. If you're new to Cloud9, probably just leave everything default. That would be my recommendation. because I want to be a little bit faster and I'm in a demo, I'll just pick a large instance. But Amazon Linux too, it's very important to use the same environment that you're going to deploy to develop to. And we'll go ahead and we'll click this and we'll run this. All right. We're creating a Cloud9 environment. This should be pretty easy. Now, I'm going to start now going to the next levels of this because we haven't even done anything with Pytest yet. We just set up the infrastructure because we're going through very methodically. But what we can do next here is actually go through and start to actually test our code and build out a bit of a structure for our project. And the Cloud9 environment is not bad. It really is a pretty nice environment. And a few things that are kind of neat about it are, one of them is that basically it has deep integration with AWS here. And if I remember correctly, if I just there might be a way to change the theme here, which is to, let's go to a darker theme. Let's try that. Does that work? If I refresh, does it Cloud9 night? Let's pick this. I'm not sure why that I picked it, but I'm not sure why it's not setting that theme. But doesn't matter necessarily too much. I must be doing something wrong why it's not setting this theme. But you can in theory change it. It looks like for some reason it's not changing for me, but let's refresh one more time. Oh well. But basically what I'm going to do here is I'm going to clone a repo. So you can clone a repo like this, or what you can do is you can just do the same command that I did before. So if I go back here and I go to code, I can clone this, and now we're in this environment. Git clone. But that is actually annoying that window is there. Oh, here we go. Yeah, so I guess it does. I guess it's the new file is the one that gets the theme here. It is interesting though that the rest of this is not. It's only the syntax theme, jet theme, terminal theme, output background color. I guess I could change a whole bunch of stuff. There we go. That's a little bit better for me. Okay, perfect. So I'm going to git clone this. So I'm going to git clone here, and now notice this will have an issue. Oh, great! It's having problems. All that means is I need to clone or set up the keys. SSH keygen -t RSA, and we'll paste this, and I will print this out and put this into GitHub. So we'll go to GitHub here, go to settings and paste this in. GitHub, so we'll call Cloud9. And all this does is make it so that I can talk to GitHub. Okay, we got that working. If I do the up arrow here, git clone, it should work. There we go. Now what's nice about using the CloudShell itself is it gives me some hints about probably how this environment will work, and everything is going to be kind of similar. And so the first thing I would do is go through here and say cd into Pytest. Because I probably will never work on any other project but this project, then I would do this. I would say Python 3-m venv. Python 3-m venv tilde.venv. So basically Python 3, there we go. That's the command I want. And I go ahead and I create that. And then I'm going to go ahead and edit the bashrc file here. And I'm going to, at the very bottom, I'm going to say basically source virtual environment. and we'll say source tilde.venv bin activate. And then and now all the great stuff that I did earlier, where I would want to open up a new shell, this should work. There we go, and we can say which Python. And notice that it's going to be the one that's in a virtual environment. And if I type on Python 3, it's going to be Python 3.7. So this is nice in that I already did some work that'll help us out, right? Because we're now testing all 4 versions of Python, Python 3.7, 3.8, 3.9, 3.10. And if I cd into this directory, I should be able to do the same thing that I did before, which is say make install. Let's go ahead and try that out. There we go. We're able to install the packages. And if I look at the hello script here as well, we could even do a lint. So I can say make lint. Perfect. And then I could also do run the script as well. So we're now ready to move into Pytest, finally, right? Because we have a structure, we can test our code in multiple environments. Let's get started with really the basics of Pytest. So I think a good place to start would be to build out more of a structure for our code itself. And this may not be exactly what we would want necessarily, is to have all of our logic in one spot. Most likely what we would want is to start building a library that has a directory of code and then start testing the library code. And so this is important because it's easy to get impatient and say, okay, let's do Pytesting. But we most likely want to actually be thoughtful about building a structure that will be maintainable in the future. So what I'm going to do next year is I'm going to say make directory, and I'm going to go ahead and call this a library of some kind. And I guess I could be simple here and just call this mylib. Let's go ahead and make that directory available. And when you create a library in Python, you would want to create a under a init file so that the interpreter will be able to import that. That's how the Python interpreter knows where the code lives. And the other thing that we could do is really move this whole hello thing really into actually like a library structure. And so probably what I could do is actually create a fruit routine. And so let's go ahead and create a file here called lib, and we'll call this fruity, like this. And then I would just probably just grab this code here and go to my lib and go to fruity and paste this in. And in fact, we can get rid of this because we don't need that. And this is a decent start here. Maybe make the code a little bit cleaner as well. Like I would say random fruit is probably a better name for this. And so we say from random import choices, random fruit, it returns back a random fruit. That's a little bit better. And then also the hello thing here, what we could do is change the way we import things. So we could say, from my lib dot fruity import random fruit like that. And now it's much simpler to actually just run this. In fact, I can just say, print random fruit like that, right? There's just 2 lines of code. And if I run Python hello, I didn't save it. If I run Python hello, it then prints this out. Now you could even get trickier here, and you could do this. You could say if under name is equal to main, and what this does is it says only run this if it's run as a script. which is even better, a little cleaner. And then we can even get even more sophisticated and even turn this into a command line tool, or at least the beginning of a command line tool, and make it executable by doing chmod plus x. And then what'll happen is we do this. We have hello, right? So we have now a simple script and we have a library. We can begin to test. And so what I would recommend with is also to think about, how do we want to test directory, or do we want to build things out based on just a script. And this might be a good place to just look at the documentation real quick. So if we look at the Pytest documentation, notice that you can run a test in a module, you can run a test in a directory, or you can run a test by a keyword expression. So maybe what we could do is let's first try both, right? Let's build a script, and then let's move it to a directory and see which one that we like more. Notice there's also tons of different options as well. Like you can profile things, you can run plugins, etc., disable things. There's all kinds of cool things that we can do here. So what I'm going to do here first, though, is just build out. We'll keep the simple structure here. So in this case, we have test hello. We may even want to change the name here to more what is in this file, which is fruity. So I'm going to say git mv test hello, and we'll say test fruity. There we go. And now that we've got that, what I would recommend is basically we can just copy this and then go to our test file. And what's nice about the way Pytest works is that you don't even need to import Pytest, unlike other test frameworks. You just need to do an assert statement. And what we can do is we can say def test random fruit. And I like to name the test basically what it is that I'm testing, so that it's clear. There's a one-to-one correlation here. So in this case, we say def test random fruit, and then what I want to do here is say assert that one of those fruits. So if we go through here, and we'll just check, maybe assert that assert that in the output of random fruit, we could even assert that this will say apple. We could do this. We could say apple. And so Python, I think, has a I don't use it that often, but I can do an or, assert Python or here, Python or. I think it's just the or, Python or. It is basically or, yeah, it's just an or. So we say or. Let's try that out. Does that work? Make test. And it didn't find that test, so we need to just double check here. And we say Pytest test hello. Oh, because we need to change it. We need to change test to fruity. And let's go ahead and run this test. There we go. It passed. So basically what I'm doing here is I'm saying, look, either apple, banana, or cherry should appear inside of this this test here. And now that I've got at least one test running, we can even tweak things a little bit and add a little more fun to this. And so what I would add is go to requirements here, and add the Pytest cov. And what Pytest cov does is it allows us, and we'll go ahead and do a make install. And then from here, we'll do pip freeze, grab the exact version. There we go. And we'll put this inside. And if we add this to our Makefile, like this, we can actually say python-m pytest, and we can say -- cov equals, and we just put in our library. We say mylib. So basically, show me how much test coverage I have in my library, and let's go ahead and do. I'm sorry, make test. There we go, and we see that 50% of the code is actually covered in Fruity. So our test potentially could be a little bit better, but we've got some test coverage, and in fact, we can even go to GitHub, go to the build process, and we can now add another step. And the additional step here should be trivial because of, again, our Makefile. So we'll go through here. It will just let's actually copy this whole line here, and let's do that. And we'll say testing Python. Make test. There we go. And now, if I say get status, let's add everything. So let's add the new build step. Let's add star, get commit, adding initial test with Pytest. There we go. And now it's going to ask me to do the same thing to just set things up here. Sure, I'll do that. Why not? No gift. And we'll add my email in here as well. And then I'll amend the reset or amend the commit here. And then we'll do a get commit should work, and push, get push. All right, exciting. Let's go back to our build system here, and let's look at what's happening. So we're now going to do actual Pytest in the build system, and we're testing actually from the cloud, really testing the code that we were architecting inside of the Cloud9 environment, which makes things a little more interesting. So let's go ahead and watch this and see if our Pytest is actually working. There we go. So we were testing 4 different versions of Python. We now have Pytest. We now have a library, and this is a great place to stop. So I think as a recap here, what we have set up is we're able to test our code from multiple cloud-based environments. But what if we want to actually learn more about Pytest? So I think a good place to start, if I was going to go through and do this, is to maybe like exhaustively go through and just start learning more and more about each of these features of the Pytest framework. And in particular, we have done this so far. We've only tested basically the module, but let's see if we can move things down. Let's see if we can move things down and go through here to the testing for our code. And in particular, one of the things that we can do here. So it looks like, yeah, video was lost for a second. Not sure why. But we can refresh here, or I can start from the beginning. And basically what we're going to cover right now is to get into the functionality of Pytest, right? So covered really how to get Pytest running, but now let's actually go through and start to do more things with Pytest and show, what you're actually able to do. So to start with here, what we can do is I can run the test in a directory, right? That would probably be a good next step for us. And so I'm going to go through here and move our code into a directory. So let's do that next. So if I go back to my cloud-based environment here, and I take a look at that, how would we restructure things? Let's clean things up a little bit here. So what I would recommend would be to go through here and to make a test directory. So let's go ahead and do that. We'll make a directory called testing inside of here. And what we can do is we can actually do a git move of the test fruity here to the testing directory. And now that I've got that set up, I would need to change the way that I run my code to reflect that. And so if we again remember the documentation, it says you run tests by passing in the path to the test directory. So we would actually change it from this to testing like this with a backslash. Let's go ahead and try it out. See if that works. Make test. And in fact, that works. So there are some advantages to putting things into a directory because it's in a sense less work, because anything that I put into that directory, it will be able to run. And so this would be a good thing for us to kind of build upon. So if we look at this library, we have one thing called Fruity, which is interesting. What if we actually build some more stuff though? Let's build out a maybe a little bit more complicated code. One of the pieces of code that I like to play around with is the Wikipedia library, because it allows me to grab Wikipedia pages. So I'm going to go ahead and add that to my requirements here, and we'll call this Wikipedia. And if I go through here, I say Python, or I say make install, this will install the Wikipedia code. Perfect. And then when I work with new libraries or a library that has like an interactive style, a lot of times I'll actually use IPython. And we can put this in there if we wanted to. We could put IPython in, and I could just say make install here. And I'll show you why I like to install this. Is the reason for installing IPython is that it allows me to prototype things very quickly. And so if I want to say import Wikipedia, I can just try out new ideas and say, okay, Wikipedia, what can we do with you? And if I do dot, it'll show me all the different things that are available. And I believe that we can search Wikipedia. That would be kind of fun. So let's say, what if I say, for example, the Lakers basketball team, it shows these different Wikipedia results here. So maybe I want to do that. Maybe I want to build out a Wikipedia search tool. So we've got that working here. Maybe I'll make another terminal too, so that I can toggle back and forth. And then if I do a pip freeze, let's go ahead and get the exact versions here of our code. So let's put in the IPython right here, and let's go ahead and do that. Let's grab the Wikipedia, and let's grab that so that we're keeping the versions that we've tested. And then let's make a new library code, right? So basically, if I cd into Pytest from ground zero, now that we have this testing directory here, let's put some more things inside. So I'm going to make something called, we'll go ahead and create a test file called testing, and we'll say test, and we'll say wiki, because this will be a new library that I write. And then let's go and let's create that file inside of my lib, and we'll call this wiki, right? So let's make a wiki library. And then inside of here, I can say import Wikipedia. And now I need to build out my library, and I can say search wiki, and inside of here, we can say potentially term equals Lakers, right? So by default, it'll search for the Lakers. And what we can do is do the same thing I did in IPython, right? So I can almost grab this essentially and put this in here, and we'll say, even make a little bit of documentation, do triple quotes, say this searches for pages in Wikipedia, like that. And then I would put in the term right here, just like that. And now what's nice about this, and let's just double check, it says undefined variable terms. That's correct. Yeah, so it'll be term, is that I could, in theory, build out basically a unit test for this reasonably well. So if I go to my test structure here, in testing, we have a second test here. I can say, let's go ahead and build out this test, and we'll say from my lib dot I called this from mylib.wiki import search wiki. So from mylib.wiki import search wiki. And now, so no, we can go down here and do another assertion. So we can say def test, and I would name it the same thing. I would say search wiki, and I would just do a simple assertion. We know that potentially this term will be inside of there. And so we'll say assert that this term is in the output of search wiki when I run it. There we go. So that looks good. And if I go back here and I type in make test, what happens? Now, there was a failure because I probably did something incorrectly. It says argument of type none type is not iterable. And what I can do here is use my same IPython as like a way to kind of play around with my library. I'm probably doing something wrong. So if I say from my lib, I type in IPython, and then say from my lib.wiki imports search wiki. In theory, this should work, but does it work? And we'll say result. Well, I don't return anything. That's why. So I made a very easy mistake here, which is I need to return back the value that I'm searching for. So the test actually was correct. And so if I exit this and I open up this again, don't know, let's save this. This is kind of annoying that term here, search. It's we don't want that. Don't save. We save. Let's refresh this. It got stuck there for a second. And let's open this back up to test wiki. That looks good. And if I say make test, did I fix it? There we go. We fix it because the library code just wasn't returning back what we needed to. But what's great about the directory structure style here is that I don't have to keep putting different module tests here. It shows me exactly the test coverage and shows me basically which files that it was able to actually test out. So really, we're in great shape here to kind of continue to build things out. Now, I would probably say that a decent way to build more and more advanced functionality for a project that uses Pytest is what we just did: A, create a library; B, create a test structure. I would say 3 would be potentially to also use a command line tool. And so what we may want to do here is actually go inside and install some kind of command line tool library. I think one of the ones that's the quickest possible command line tool library that you could use is Python Fire. And so if we go through Python Fire here, it really can help us kind of build tests quicker. And the reason why is that we can very, very quickly try some library code that we wrote. And I've found that it really is a pretty helpful system. So if we go through here and I say import Fire, I could just put this at the bottom of some code. And that's kind of the basic usage, but you also can call it on a class as well. And it will actually let you execute the different things inside of a class. So there's some really cool things that you can do with Python Fire that I find to be conducive for writing tests. And so let's go ahead and add this thing in there as well. So let's go to requirements and let's add the Python Fire here. And we'll say make install. That looks good. And we'll say pip freeze and grab Fire. And we can grab that version here. And then the hello, we can just make it a little bit trickier, right? Because we potentially, I guess what we could do is we could actually build a command line tool here that allows us to kind of test things out a little bit more. So I could basically take the Python Fire example here, just grab it and paste it inside, and then also go to the wiki here. So we can say from my lib.wiki imports wiki search. I think it's right. Is that correct? From search wiki import search wiki. There you go. Search wiki. And then this here, we don't even need to even build even a function here. We could just go through here and say, search wiki and call it. And if we needed to now run it, we would just say Python, or in fact, we would just do this. We just say hello, and it says Fire is not defined, so we need to import Python Fire. Import Fire, like that. And now run this, hello. And so it's able to actually do this. And I think I can just pass in as well term equals warriors or something like this. Does that work? So it says available commands. If I go to Python Fire, -- name is equal to world. It should be, yeah, this should be working here, which is term. Yeah, not sure why that's not working, but I'll figure it out later. Basically, generally it'll actually grab whatever it is that I needed needed inside of a function. In this case, it would be search wiki, and you would pass in the thing that it's actually grabbing, which is, but if we go through here, we see search wiki. Let's just double check that I'm using Python Fire correctly. Oh, I didn't do it that way. I'm invoking it. That's the problem. So I need to do it this way, right? Like this. And so now if I run term, there we go, right? And we can say Lakers, right? Or we can do the Celtics, right? There we go. So we have some cool stuff working here. Git status, git add. We'll add all this code inside of here. Adding basic CLI. And so the reason I like to do the CLI for Pytest is it's just a very, very quick way to invoke different ideas and then also help me build out a test structure for Pytest. So what else can we do though? So we've done the module, we've done that, we've done the testing, but what if we wanted to just run a test that matched, some kind of keyword here? So what this does, it says this will run a test which contains the names that match the string expression. So this is kind of a cool concept here, which is that I can basically say, like I can basically run a style of a test here. So let's try this one out as well. Let's just say add a section that says using Pytest, and I'm just going to go through some of the functionality that's the things that we can do. So we already did the library. So use library style, right? Which is the thing that we just did, in fact. And I'll even put this. I'll put this into copy what we did in the Makefile, right? So this would be one thing you can do. Using library style. And then the next one that we could try out would be like testing via a phrase. And so this is right here, right? Run tests by keyword expression. Let's go ahead and do that one next. And so how would we do this? Well, we could do, really the start of it would be this, python-m pytest, and we would do -vv-k, and then we just need to put an expression inside of here. And so this could be, like search, for example. So if I do that and I run it here, we can actually get this thing working. So what this will do is, look, it'll only look for tests that match that pattern, and it'll only run that one test, which is really actually pretty neat because it allows me to just test maybe like the library I'm working on really, really quickly if I'm in a huge code base. So if I go back into the test library, look, we also have the fruity one as well, right? What if I wanted to test fruit, right? So we could do the same thing. We could go through here and we could say, well, what about fruit right here? And this should test only, there we go, only the test that matches the fruit. So that is actually quite nice to be able to limit the test by keyword expression. Well, what else can we do? In fact, I'll just move this thing close here, is we can also test a specific module as well. So let's go ahead and do that. And we can add that as a note. We'll say to run a specific test within a module, and we would invoke it something like this, and we can actually put this here. It would look something like this, but we would want to run it this way. We'll say Python m Pytest, and then I just need to actually name the module. So it would be, in my case, it would be testing, and then it would be the test fruity, like that, and then in fact, I could just grab the exact name here. It would be test random fruit. So you can be really explicit as well if you wanted to. And let's see if this one works. If we said test fruity like that, test random fruit. So if I go through here and I run this exact command, what happens? There we go. I was able to test just that one file, and we could actually add a little bit of verbosity to it, so we see a little bit more of the output, right? And I would just do that, and so I could grab this whole thing here, and we can see that we can do this. There we go. Perfect. So it is nice to know that you can do both a keyword expression style or a very specific test. In fact, and what I'll do is I'll do check in this README as I'm building it, so other people can run the same thing. So adding examples. The next step here would be to basically check this in so that other people can get access to it. And now, what is nice though is you also can do a marker as well. And so let's go ahead and try that next. And so let's go ahead and put this node in here to say run a marker like this. Run test by marker expressions, and so we'll do this, run test by marker expressions. And so what we would need to do is mark one of our pieces of code with some kind of like command. So this could be, let's say, the MongoDB integration or something like that. And so what I could do is just take a look at how we would do the marker. And so I would say probably the easiest way to do the marker would be to either build an INI file like this, or to actually put this decorator inside of a piece of code here. And so you can, here we go. He says you can register new markers programmatically in a Pytest hook configure or in your file right here inside of your code. So this is another neat little trick that you can do that, again, if you had slow code or you had some other kind of example here where you wanted to segment out your code, you could actually go ahead and do this. So I'll just put a link to that here. What's next that we can do? So as I've been doing this quite a bit, as I've been doing the dash version quite a bit, and so the verbosity, but it is actually neat that you have a lot of different options with Pytest in terms of command line configurations, and you even can profile your code as well. And so you could say basically, and let's try this. So get a list of the slowest 10 test durations over 1 second long. So I'm going to go ahead and paste this in here as well, like profile the tests, right? You could do something like this. And so what I'll do is actually potentially add this into my Makefile, and we'll say profile test code like this. And we can actually use the first part of it like this, and we can set up a profile. So show things that basically, in this particular example here, get a list of the 10 test durations over 1 second long. By default, Pytest will not show test durations that are too small unless -vv is shown in. So if we do this, if I say make, we'll save this. If I say make profile test code, we could run this test profiler. So make profile test code. Profile test code. There we go. And in particular, this example here shows us that we actually show the 10 slowest durations here would be that this is 0.44 seconds. The setup, teardown, and call of these are also shown up, and so it's kind of nice in that if I did have a really slow test, they would actually be something I could maybe investigate and fix. In fact, why don't we do that? Why don't we build, in fact, a really slow test? And so what I could do is I could actually intentionally make things slow. So let's go ahead and say from time import sleep, and let's build out a slow test. We'll say test slow test, and we could basically just do the same thing that I did here, but I'll just make it intentionally very slow. And so I'll say sleep, let's say 3 or something like that. And so if I go through here and I do the same thing, let's say make test, let's verify first that it takes a long time, right? You can see that this test is slow. And now if I go through here and I say make profile test, it's going to show exactly that this slow test took 3 seconds here. In fact, I might even be able to go back to my Makefile, and let's just say I want to find only the tests. I just want to find the slowest test. That's it. And let's go ahead and do that. And it should print out here. Basically, look, yeah, this is the test that's slow for us. We need to be careful about that particular test. It's been, cutting, giving us issues. And this really can be, pretty useful to have the ability to kind of toggle things in terms of seeing why the tests are taking so long, which can be a real problem when you get into a larger code base. So again, we'll say get status. We'll go ahead and add this and commit, adding the examples of slow tests. Perfect. All right. So now that we got the slow test here, all taken care of, what is the next thing that we can do? Well, let's just keep moving. So you can also do early loading of plugins. You can disable plugins. This is what I've been doing. I've been doing the calling Pytest here by doing the -m here. Well, I think skipping would be a good one to get into next here, which would be skipping. So if we go to skipping a test here, in fact, I want to skip the test because one of the things that is nice about the skipping is if something potentially is slow. And so basically the simplest way to test a function is to mark it with the skip decorator, which may be passed as an optional reason. And so if we go through here, we can actually add this on top of our code. So let's actually add a little documentation here. And we'll say, for example, in the README here, we'll say, what about skipping tests? Skipping. So you would do something like this. And if we go to the one I want to skip that's annoying is the slow one now, because we made it intentionally slow. And I would just put in some information here. I would just say, yeah, reason too slow. This test is too slow. And I added a sleep. There we go. That looks good. And no variable named Pytest. Well, what I need to do is actually import Pytest, because now we're using the advanced functionality of Pytest. We're able to I think get this working. I don't know why that's taking a second, but there we go. It figured it out. So if I go through here and I say make test, very fast now, because look, it says this test is too slow. and I added a sleep. So this really is pretty cool that I can actually just skip tests that are annoying, which then you could always later, if we go back here, you can toggle it, and you could actually basically not skip the tests that are slow for some of the things that you're doing. You could also add skips as well for platform specific issues, which is pretty cool. You could also skip, maybe certain directories as well. But the skipping is definitely a neat little trick to do to make sure that you're able to kind of test the parts of your code that you actually want to actually test. So let's go ahead and do that. Let's say git status here, add all these in, and we'll say commit, adding skipping example. Now another example that I think would be kind of cool to cover is the concept of like doing tests in parallel. So how would you do this? Well, let's go ahead and try this out. Parallel. And if we go through the documentation, and so one of the things that you could do is, flaky test. A flaky test is one that exhibits intermittent or sporadic failure, and this is non-deterministic. And this really is a problem, and they're making this example here is flaky tests are particularly troublesome with continuous integration. And so sometimes when you're running things in parallel, like if you're using Pytest xdist, for example, that could potentially be one of the issues about doing things in parallel. So let's go ahead and take a look at this Pytest xdist here and see, potentially how it could both solve some problems and also introduce other problems. So Pytest xdist here, this is a plugin that extends Pytest with new execution modes. The most being used is distributed tests across multiple CPUs to basically test this out. So if we go ahead and we take a look at this, you can see that we can install Pytest dist, and then to use psutil for detection, install the psutil extra. So let's go ahead and do this. Let's go ahead and try to get distributed testing available as well, that uses like a basically multi-core functionality. So the first thing that we would do we would need to install this module as well. So I'm going to put this inside of the documentation. So we'll say distributed testing. So distributed testing, here we go. And we can add in this thing right here, distributed testing. And in particular, this might even be its own section. So I can do like a triple quote or triple hashtag distributed testing, and we'll say install like this. And the next thing that I would probably say would be that we would want to edit the requirements file. So we'll go here and we'll add in the code that it's telling me to do, which is Pytest xdist right here. And we'll also go to Pytest xdist psutil, which is right here. So we have Pytest xdist, Pytest xdist psutil, and let's go ahead and do a make install. There we go. Let's go ahead and do make install. And now if I do a pip freeze and I grep for Pytest xdist, I can grab that, grep for Pytest xdist. That didn't, I didn't save it. There we go. Now I'm going to save it. Make install. And now if I grep it, we should see this Pytest xdist. And I think I can grep this potentially as well, and make sure that this one shows up. Okay, so it looks like we're able to install this utility And now the next thing that I would do is we can actually basically send multiple CPUs using -in here when we do the test. So I think one of the things to think about would be, first, let's see how many CPUs are available on my system. So how would I do this? I could type in IPython and say from, or I would say import multiprocessing. And then I would say multiprocessing dot CPU count, just like this. There we go. And so we have two CPUs that are available here that I could actually use. Now, if I wanted to spin up another machine, that's definitely on the table. That could be an interesting thing to do, but let's just use 2 CPUs since I know 2 are available. So how would I use this? Well, I could just go again to my Makefile, and I could add I could do something maybe called parallel test, like that. And inside of here, what I could do is I could actually just copy what they say, which is send test to multiple CPUs doing basically in test. And so the auto would use as many processes as your computer has cores. This can lead to considerable speed ups. So probably I would say auto might be a better approach for us to do this. So let's start off with that. Let's do, let's keep all of this working here. So let's just grab this code like that, and let's put auto here, and let's just see if this works. Pytest number auto. Okay, let's see if we can do a parallel test. So make parallel test. Parallel test. And there we go. Wow, that was faster. So basically, notice here that that it was able to actually, I believe, split these up. Although let's see what the documentation here says. So it says the test distribution algorithm is configured with the dist command line option. And so dist load sends pending tests to any worker available without any guaranteed order. That's the default. The load scope, the tests are grouped by module for test functions and by class for test methods. And so you could even break this up into different groups as well, which is kind of interesting, which might be worth playing around with. So if I wanted to get rid of that skipped test, for example, or recreate it, let's go ahead and let's try to do that. So if I go back to the file that is here, which is the test wiki where we have the skipped test. Let's build another one that's actually essentially the same thing, but basically we won't skip it. And so we don't skip this thing. And now what we can do is we can say test slow test parallel. So we want to run this in parallel to see, like, in theory, because it should be able to fork this off, that it should still run pretty fast. And so we could even do it. We could say make test parallel, and let's see that is still, we could even do a time operation. No, I guess it took 4 seconds total. But what I don't see here, what if I could run this thing in its own, well, I guess what we could do is we could do 2 of these. So we could do parallel A and then parallel B. And that way we have 2 slow tests. And so in theory, this should be able to basically speed it up, right? Because if we have 2 sleeps that are 3 seconds, it would normally take, let's say, 6 seconds or 8 seconds. But let's see what happens if we run it in parallel. And so if I go ahead and do it in parallel, it's basically right now doing it sequentially, and so it's taking 7 seconds. So I think what we could do is we could break this into groups, and so sends penny test to any worker that's available without any guaranteed order. The tests are grouped by module, by test functions. Tests are grouped by their containing files. Tests are grouped by the xdist group mark. And so groups are then distributed to available workers as whole units. This guarantees all tests within the group run in the same worker. So I think this is what we want to do. So we can try this out. I've never done it before, but I'm conceptually, I know what's happening. So if we say this, we add xdist group, we'll say group A, and then let's add another one for group B, and we'll say group B. And what do we need to do next here is it says you would do load group right here, or load group. Yeah. So let's do --dist load group. So in theory, this should speed it up. If I go back to my Makefile and I do load group. So what happens, is it faster than 7 seconds? We're about to find out. And no, it didn't speed it up. So that is kind of curious about why it's not faster than 7 seconds. I don't yet know, unless I add. Maybe I didn't save it. Let's see. Let's save this Makefile here. There we go. Let's run it one more time. Run it a couple times here. Yeah, it might take a little bit of tweaking to figure out how to make this faster or not. I guess I could basically make it really explicit by overloading one group. So if I made like 3 of these or something like that, like this would be, let's make one more. We'll call this one still group A. We'll call this one A2, and we'll call this A1. And then let's add maybe another one down here and do group B, and we'll call this B1, and then do another B2. B2. Okay, so if I just run this regularly, this should tell me how long it should take. It should take quite a while. So we're basically doing a 3 second, 3 seconds, that's 6 seconds, that's 9 seconds, that's 12 seconds. So yeah, 13 seconds total. Now, if I say parallel test, in theory, we should have some kind of speed up. If it's not slower than 12 seconds, then maybe I'm doing something wrong. Yeah, so it's actually, in fact, slower. So it's possible that I'm not doing the parallelization the way I think it is, or because it's only a 2-core machine, maybe it's not enough. So what we could do, which would be kind of fun, is let me check in all this code, and let's just get a bigger machine. So that's one of the nice things about the cloud, is adding code for parallel. Is let's really double check this thing and see if the problem is it my code or is it the environment. Fortunately, we can swap things out very easily. So all I need to do is go to Cloud9 here and go and spin up a bigger box, and we can say create environment, and we'll call this big test machine. And it's pretty easy to pick a big one because we just go to other instance type here, and we can find potentially a large machine. Let's pick something really big. Let's pick 32 core, right? That'll be a good one. Or no, look, here we go, 36. There's a good one, 36 core machine. And let's spin this up. All right, let's create environments. Okay, we're creating a Cloud9 environment. This can take a few minutes. This shouldn't be too long. And the only thing I need to do is add the SSH keys to it and see if that actually works. Okay, so we can, while this is opening up, there we go. So I'm going to have to check out my code again, which is not a problem. I'll go to my repo, grab the link, copy this, put it into the big test machine, git clone. There we go. Yes. Now it's not going to work because I have to create the SSH keys. So I'll do that. SSH keygen -trsa. Let's paste this key inside. So let's go ahead and do this. Cat that. And we'll put this into our GitHub new big machine. Okay. Now, just create a Python virtual environment real quick. And source it. And here we go. Perfect. And now I can do the git clone. So just go up here, git clone, cd into Pytest like this. And perfect. So we got this thing, and now I can actually do a make install, so I can get all my stuff in here. And this is a very fast machine with tons and tons of RAM. And in fact, we should be able to easily verify how many cores. In fact, what I'll do to make things fun is I'll actually build a little script here that will show us the cores. So we'll say touch cores.py. And then we can just do this, right? We can just be lazy. We can do this, user bin env Python, and type in print or import multiprocessing, and then do print multiprocessing dot CPU. Is it CPU cores, or let's type in import multiprocessing and multiprocessing dot CPU cores, CPU count. There we go. That's what I need to do. CPU count. There we go. And we do that. So now I'll just exit this. Exit and Python core 36, right? So 36 core machine, big machine. And then I'll even check this in for people. So git status, git add core, commit this, adding CPU cores. I kind of don't care about this right now. So we got that checked in. Now I'm kind of excited. Let's go ahead and see, does our, first let's run a regular test. So we'll say make test. Okay, and this should take a while. Right, 3 seconds, 3 seconds, 3 seconds. So 12 seconds. Now if I do make parallel test, what happens? Make parallel test. whoa, it's definitely looking different. And it was definitely faster, right? So if I think when it's on a 2-core machine, it really may not actually work that well, but obviously this cut the time in close to a half by using a big machine here. So I think this is actually not a bad concept, really, is to think about using basically multi-core to test your code. In fact, if we go back to the our repo here as well, we should actually look. We see there's some kind of a problem I introduced here, which I don't. Let's see what the problem is. So analyzing code with Pylint. So I have some bad test code here that I would have to fix at some point as well. That's probably why I had some issues with my fixtures. But basically, I guess what I could do is just delete those fixtures since I had some issues with it anyway. So let's even do that. Let's delete those fixtures for now, and we'll say git rm testing test fixture, and let's just fix our code. We can get to that later. Removing crappy tests. There we go. And git pull. There we go. Right out. And exits. Git pull. Or we can do this. Git config. Git pull. Git push. There we go. And let's see if that fixed our problem here. Because what I'm curious to see is how also the build system does our tests as well. Because depending on, again, what kind of project we're building, it really could have very different runtime characteristics, right? Because, or actually what kind of build we're running, and also what is the build server itself capable of doing. And this one is analyzing the code, and it says test fruity redefining. So I still have that problem that I need to fix real quick. And so if I go back to my testing, this thing is, once you write some bad code, it can take a while to get rid of your bad code. So yeah, this whole routine here is just rip it out. I need to revisit it. It just was not a good test. So if I say make test here, there we go. We got this thing. Okay, so this appears to be working. Or I could say actually use my own speedy code here. Is right. We could say make parallel test like that, and it's going to be super fast. Just a few seconds to run it, even though there's tons and tons of slow tests in here. So we'll say git status. There we go. Git add testing. Git commit. Fixing broken fixture. Okay, so we got that. Or git pull. Write it out. Exits. Git push. Okay, so let's test this out here. Inside, what happens? It's going to now run our in theory, our code should run in parallel now, because we're using the parallel library. So it's going to try to install the new parallel extension for Pytest, and it's going to, in theory, analyze the code with Pylint, which it's still, wait a second, why is this having issues? Oh, bad indentation found and unused import. Aha, so this is actually good timing, because we haven't used some of the tools at our disposal here. So what we could do, so first of all, I'm going to fix this annoying commit thing, which I'll just do real quick. Let's fix that. And then we'll go through here and we'll fix this. And okay. And then we'll amend the commit message. Here we go. Okay, exits and get commit, get pull, do this, fix this stuff here, get pull, get push. There we go. So one of the things that we can do is basically do a make format, and this will fix some of the issues of like spaces and all these other problems. And in fact, let's look at this. See, it actually has an impact on the build system. And in this case, we say it's going to do everything in our current working directory, but we also could potentially do the same thing they're doing here. What if we did this? What if we said, we said, look, why don't you look at everything in the project? So that's a cool little trick I just learned. Look, it does more things, right? Because it does a git list, shows me all Python files in my project, and it reformatted all of them. And then I think the other thing I was missing was, look, I don't need this anymore because that's a lint issue. And now if I say make lint, we're able to fix it. So really, we're able to use, there's a lot of dependencies on the code being formatted correctly, the linting being working, and the testing being working, and they all are co-related, and all these tools work together. So now, if I say get status, we change a bunch of code, we'll add this, we'll say fixing lint and format issues. And we'll push this code to the build system. The build system, hopefully here, will be able to be fixed finally, because it's been broken for a while. And we can test the parallelization, which is the thing I really was curious about. Okay, here we go, and we're testing now. And how long does it take to test our code, and how many cores does it actually use? So it took actually 44 seconds. So this build system may not be super fast. This took 35. So when we go to the testing section here, this is not a very speedy build system, and so it doesn't fully utilize the parallelization components of what we had in our project. So it's just something to be aware of, is that it does depend obviously on the speed of the machine that you're testing with. So maybe another thing to cover with Pytest would be to also show how you could use different build systems. And in particular, since we've been on the AWS ecosystem, one of the things that we could do is go into the build system for AWS. So I'm going to go to console, and I'm going to go to the build system that they have available called Code Build. And if we go to Code Build, it's actually reasonably straightforward. It's similar to Pytest projects like we're doing with GitHub Actions here. If I say create build project, we can go ahead and say test or Pytest experiment. Maybe put a hyphen in here or something like that. And say verifying how Pytest works on the on AWS build system. And so we can do similar things, right? We can build a badge if we want to. We also will pick the repo. I'm going to pick GitHub. And our repo is called Pytest from ground zero. Okay, let's do that. And we'll find it, Pytest from ground zero. Should take just a second here. Not sure why that's not popping up. Here we go. Okay, no gift Pytest from ground zero. That's it. You can do all kinds of fancy stuff here, like clone depth and things like that. But basically, the main things I care about are I do want to rebuild it every time I push a change. And I also want to use a managed image. So I basically want to run it in the same environment as my big machine here, or like something similar to it. So I want to use Amazon Linux, and I want to pick the runtime to be like a runtime here. That's the latest runtime. In this case, I don't really necessarily need to do anything advanced. So I don't necessarily need to create a new service role account. But I have one already that I usually use that I know works. This would be if you needed to do things with AWS. We're not doing anything with AWS, but just for the fact that I don't want to have problems, I'm going to use a role that I've typically used in the past. And then you could even configure more advanced things here, like timeouts or compute environments, like what kind of machine. Now, this is kind of an interesting one because notice that was one of the things I wanted to play around with was, okay, well, I want to speed up our build by running it in parallel. Well, let's try that. Let's try a big machine, right? A 72 core machine with 145 gigs of RAM. That looks good. That's kind of fun. And then, okay, what about a build spec file? Yeah, we could do this. We could basically use a build spec file to run our build. Now, what I'm going to do is I'm going to go to another project I had recently set up where I was using build specs, and I can find basically Fast API, I think maybe was a project that had this. Let's find build spec in this user. Let's find all my build specs. Here we go. This, I think, would be a good repo to do that. So here we go, build spec. Yeah, so you can make a very, very simple build spec like that, which is the config file. So I'm going to go ahead and grab this build spec, and it's called buildspec.yml. So let's go ahead and do this. We'll say touch buildspec.yml like that. And now we'll go ahead and we'll throw this in. So notice what is kind of cool about this, because we get to go back from where we started at the very beginning, is that we have a Makefile here that will do all the work for us, and we don't really all we need to do is just make sure that this does what we want it to do. So what does a make all do? Install lint test. Now, because I want to do parallel testing, I'm going to swap this out right here. So I'm going to say parallel test as the make all. Instead of regular test, I want parallel test in here. So I want to install the code. I want to lint the code. I want to parallel test it. And I also want the code to be formatted so I can see if there's formatting issues that I need to check in later. So that looks pretty good. So let's go ahead and say get status. Let's add the Makefile. Let's go ahead and add the build spec. Let's commit it. adding big build on AWS Code Build, right? Because it's going to use a huge machine here to test this out. So we got that. Now all I need to do is go back to Code Build here and just say, yeah, use build spec. Everything looks good. Now I think there's a build badge option here as well that I want to enable. And let's find that build badge. Rebuild every time. Where's the badge? Yeah, enable build badge. Okay, got that enabled. Okay, this looks ready to go. Let's go ahead and create the build project. All right, let's, you cannot have more than 0 builds in the queue for the account. Cannot have more than 0 builds in queue for the account. I don't know what that means, but we can Google it. Maybe I can't launch that big of a machine. Let's see here. Can I have, let's see. Yeah, I think it's because the machine, my error was, yeah. I think it's I'm asking it to do too big of a machine. So we can just make it slightly less big of a machine. And so if I go to here, we just need to change the environment here somehow. Let's see, source environment. Let's try this. Here we go. Let's try the 8-core machine. And let's see if it lets us do that. I bet you that's it. Yeah, that was it. So that's too big of a machine. You have to like call them up on the phone and say, no, really, I want a machine that big. So let's see this thing in action. But it does have 8 cores, which should be, I think, hopefully reasonably fast. We click on tail logs here, and we should be able to see the parallel Pytest builds. Okay, let's watch this thing go here. It is taking a little bit of time. I don't know why it's taking so much time to run, but it's still in the provisioning phase. There we go. It looks like we got something running here. Start time 1 minute ago. Yeah, typically this is, at least when I use the AWS Code Build, it's pretty quick. Not sure why it's taking a little bit of time. But let's check this out. Not sure why this is kind of taking a bit of time to run. Very weird that it's taking this much time to run. So we submitted this. We see the build details. We see the environment. It's a 15 gig RAM 8-core machine. And we could even look at how much CPU it's using, which is pretty useful depending on what problem you're trying to solve. Here we go. So here's our logs. So it finally got into the build process. It's installing things, and we can watch the build run. There we go. So it's actually doing, look, we can see that there is multi-core testing happening, which is pretty cool. And let's see here how fast it was able to run. So look, so even this 8-core machine was able to was able to speed things up, which is pretty cool. And now if we go to the build project as well, see this copy badge, we can go back to here, go to our README file right here, and we could add our second badge, which they make it hard for you because you have to put this in yourself, but we'll just say basically build 2, and then do Control E, get to the end here. And so now I can check this in, status, git add, readme, adding AWS Pytest badge. So once I do this commit, it's going to now fork. It's going to be basically running in two different environments. So it's probably worth at this point just sketching out what it is we did to close out the day here, and what are some of the problems that we solved by doing this particular method. So what we have is at the source of truth is still the GitHub repo, right? So this is the middle of where we were at. And inside of the GitHub repo, we were able to actually go through and get everything tested by using GitHub Actions. GitHub Actions. But then we introduced a twist here by actually also letting ourselves develop in another cloud. And so we have the AWS cloud right here, call this AWS. And inside the AWS cloud, we used their cloud-based development environment, Cloud9. And initially, we just went back and forth, right? We went to GitHub and pushed the code, and that triggered the build process, which we were using. And there's lots to like about that process. But what we also introduced was a second. We introduced a second process, which is basically another build system, which is AWS Cloud9 or AWS Code Build. And AWS Code Build tests literally the exact same environment as my Cloud9 environment. So they're basically in the same cloud. It's got the same operating system, right? In this case, we would even say like Amazon Linux was what we were testing against. And so it does give us in some ways advantages over just vanilla GitHub Actions, because you're running it in Ubuntu, and there could be tools or different things that you need that you're getting for free by using Amazon Linux. And then the other thing we also verified was and we'll put a little note here, is we were able to do the parallelization, right? And we were able to test out on basically very easily just swapping out a machine. We were able to test it out, and also we were able to test out as well that same parallelization here. This was an 8-core machine that we were able to test it out with, and this one was 32-core machine. So we were able to test out lots of different scenarios by actually using more than one environment. And so in the real world, it is possible you may want to test your code in multiple types of environments, and maybe you could even test like a subset of your code with GitHub Actions, and then maybe a different piece of your code inside of AWS Code Build. It really kind of depends on the problems that you're trying to solve in your organization.